This is the solution video for section 7.3, problem number 15. All right, so I have the integral from -3 to 6 of the absolute value of x minus 4 dx. Now, you need to consider a graph of this. All right, so when we look at the graph of the absolute value of x minus 4, we know that that is the absolute value graph that has been shifted to the right 4 units. Right now, if this is like y equals x minus 4, right, that is a slope of 1, y-intercept of -4, right? So we have a slope of 1 over here, right? But then we also have y equals the opposite of x minus 4. So that'd be a slope of -1 and a y-intercept of +4 when x is less than 4, right? So that's our graph, right? And so now if I want the integral from -3 to 6, so this is 4, 5, 6, right? What we have is essentially just two triangles, right? Now, the other way that you can do this is you could consider the integral from -3 to 4 of the opposite of x minus 4 dx, and then add to it the integral from 4 to 6 of x minus 4 dx, right? So you could consider those separately, but when we consider this graphically, it's actually just easier than that by finding the area of these two triangles. All right, so now on the left side, this triangle goes from -3 to 4, so it's 7 wide and 7 tall, right? Because if I plug in -3, I get -3 minus 4, which is -7, absolute value -7. So this point is -3, 7, right? So it's 7 times 7. So half of 7 times 7 is going to give us 49 halves. And then plus, all right, this goes from 4 to 6. So that's a 2 by 2. So half of 2 by 2 is 4 halves, right? So now if I add these together, I get 53 halves. So 53 halves would be my area, which would be what you'd get if you would do the sum of those two integrals down there. All right, so that is problem number 9.